Hello everyone. In this video we are going to have a look at the very basic concept of mathematics called factors and multiples. Before proceeding to the video, I would suggest you to grab a pen and paper so that we can do some maths together. The numbers that divide exactly into another numbers are called the factors of that number. While multiples are the number that obtained after multiplying the number by an integer. So now let's see how can we find the factors of a number. For example, if we are taking a number 60 and we need to find the factors of a 60, we'll start our to find the factor with the number 1, as we know that every number is divisible by number 1 and the number itself. Then we'll proceed to the next number or the higher numbers, and we will keep multiplying the numbers until we reach to the point where we can see the repetitions of a number. So in this case, 6 times 10, what will be the high? Yes, 6 times 10 is equivalent to the 60. And what could be the next possible numbers? Is the 60 is divisible by 7? No. Is the 60 is divisible by 8? No. Is the 60 is divisible by 9? No. But the 60 is divisible by 10. 10 times 6. But we have already seen that we have already got 6 times 10. So that will be the repetition of the number. So we have to stop here. So the product of this, the factors of the 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. So these are the factors of 60. This is how we find the factors. Or we can say that 60 is the multiples of these number. For example, if you multiply 4 times 15, you are getting 60. So 4 and 15s are the factors of a 60, and 60 is the multiple of 4 times 15. So now we know how to find the factors of a number. Let's do a small exercise. We need to find the factors of a number from 2 to 10. So let's do it together. So factors of 2 are 1 and 2. Factors of 3 will be 1 and 3, as 3 is not divisible by any other number. And the factors of 4 will be, is the 4 is divisible by 2? Yes, it is. So 1, 2 and 4. These are the factors of 4. Let's see what's happened with number 5. 1 times 5 equivalent to 5. 5 is not divisible by any other number. So the factors of 5 are 1 and 5. And the factors of 6. 2 times 3 is equivalent to the 6, and 3 times 2 is also equivalent to 6. So 1, 2, 3 and 6. We have 4 factors of 6. And what will be the factor of 7? Any guesses? Yes, it's 1 and 7. So as you can observe, there are certain numbers which has only 2 factors, the number itself and the number 1. And there are the other numbers which have more than 2 factors. So what will be the factor of 9? Any answer? No, we will start with the number 1. I make a mistake, sorry. 1, 3 and 9 are factors of 9. And finally factors of 10. 1 times 10 equivalent to 10. 2 times 5 and 5 times 2, so we don't have to write it again. 1, 2 and 5 are factors of 10. So we have observed that there are numbers which have only two factors on the number 1 and the number itself, and there are the other numbers which have more than two factors. So we categorize, or we divide the number into the two category. The number which have only two factors are called the prime number, and the numbers whose factors are more than two are called the composite number. Now let's find the prime number and composite number from number 2 to number 10. So the 2 is prime number as it has only two factors, number 1 and number itself. And 3, is it a composite or prime? Yes, it is prime number as it has only two factors. So 3, 5 and 7 are prime numbers, while number 4 has more than two factors, so it will be the composite number. Number 6 is also have 6, 8, 9 and 10. They have more than two factors, so they are composite numbers. 1 and the number itself is a prime number, while a number which has more than two different factors is a composite number. So far we have learned how to find the factors of number and how to categorize the numbers on the basis of the factor, either it is a prime number or the composite number. So where do you apply this knowledge? So let's have a look into the problem that requires your knowledge to find the factors. What the problem states is that Peter has 48 strawberry flavor sweets. John has 45 lemon flavor sweets. Okay. They wish to divide their sweets equally into bags. And the question is asking, can you help them to list all the possible ways they can do this? So we need to find the combination of the sweets in the bags, because they have to divide their sweets equally into the bags. So in order to do this, what will be our first step? Our first step is going to be to find the factors of 48 and 45. That will give us the combination of numbers they can utilize to put their sweets. So we have already taken we have already find the factors of 48 and 45. So what will be the possible combinations of bags and sweets? So Peter can make the two bags of each of 24 sweets, or 3 bags of 16 sweets, yes, or 4 bags of 12 sweets, or 6 bags each carrying 8 sweets. Or it can be the vice versa. So he can also have 8 bags of 6 sweets, 12 bags of 4 sweets, 16 bags of 3 sweets, or 24 bags each carrying 2 sweets. So these are all possible combinations for Peter, who wants to divide his 48 sweets equally into the bags, number of bags. First, okay, and the other for the 45, we can have 3 bags of 15 sweets, or 5 bags of 9 sweets, or and the vice versa, 9 bags of 5 sweets and 15 bags of 3 sweets. So these are all the possible ways that they can make their bags. Okay, now the second part of the problem is that now they want to combine the sweets and divide them equally into bags in such a way that each bag has equal number of both flavor sweets. As they want to combine the sweets, we have to find the common factor. So, the common factor between the 48 and the 45 is the 3. And we can see when the Peter and the John had 3 bags, the number of the sweets of the Peter was 16 and the number of the sweets of the John was 14. So, they can make they can have the combination of 3 bags, each will carry 16 Peter sweets and 15 John sweets. So, yeah, that will be the solution. So far we have learned a number can be a prime number or it can be a composite number. And the interesting fact about the composite number is that it can always expressed as a product of 2 or more prime factors. And the process of decomposition of composite number into prime factor is called prime factorization. Let's decompose a composite number into a prime factor. If I'm taking number 36, I want to find a prime factor. The first method is called the factor tree, in which you do the prime factorization like this. Like if we have taken 36, we keep factorizing the numbers into the prime number. So 2 times 18 equals to 36. 18 can be further divided into 2 times 9, and 9 is further divided into 3 times 3. At this stage we have got all the prime numbers, so we have to stop our factorization, and we are getting the answer 2 square into 3 square, 4 times 9, which is equal into the 36. And the second method is simply the division method, in which you take the composite number and you keep dividing it. You start with the smallest number and keep dividing until you reach to the point where you get the 1 as a remainder. So in this case we have got 2, 2, 3, 3. So answer is the same. You can adopt either this factor tree method or the division methods. So choice is totally yours. So yes, we are getting the same answer. So far we have learned what are the factors, what are the prime numbers, composite number, and how to do the prime factorization. So here is the problem that requires all your knowledge. The problem is that stating that like John has to completely cover a wooden floor measured 90 centimeter by 120 centimeter with the identical square tiles. Can you help him to find the length of the largest side of each tile? Also find the number of tiles that are needed to cover the floor. So here is the pictorial form of the problem. The wooden floor is of a 90 centimeter and 120 centimeter, and he has to cover this 90 centimeter and 120 centimeter wooden floor with the square tiles, and we need to find the length of the square tile, and after finding the length we also need to find the total number of tiles that are required to cover this 90 centimeter and 120 centimeter rectangular wooden floor. So as we can see from the picture that each tile is sharing some portion of this side, that is of a 90 centimeter side, and some portion of the 120 centimeters side. So we have to find something common between the 90 centimeter and 120 centimeter, and from the common what I mean is that we need to find the common factor of 90 centimeter and 120 centimeter. So let's decompose this 90 and 120 are obviously are the composite number, as they have more, they must have more than two factors. So let's decompose these numbers and find the common factors. So let's decompose the number 90 and 120 into prime factors. So I'm doing prime factorization. So 2 times 45 equal to 90. 45 can be further factorized into 3 into 15. 15 can be further factorized into 3 into 5. So we have got the answer 2, 3 square and 5. So let's see what's happening with 120. So 120 can be divided into 2 times 60. 60 will be further factorized into 2 times 30. 30 will be further into 2 times 15. And 15 can be further divided into 3 times 5. So we have got 2 2 2 means 2 cube into 3 into 5. So we have a 3 common factor here, 2, 3 and 5. So common factors are 2, 3 and 5. We don't take the highest number, we take the lower index value notation number. And the highest common factor are the multiples of these factors, 2 times 3 into 5, which is equivalent to the 30. So this is the highest common factor. We call it as a HCF or highest common factor. So this was the factor tree method of prime factorization to find the highest common factor. The other method to find the highest common factor is to use the division method of a prime factorization. So this is how we use the multiplication division method to find the highest common factor. We write all the numbers in a line in a row, and we start dividing with the lowest common factor in between them. So 90 and 120 is divisible by 2, 45 and 60 is divisible by 3, and 20 and 15 is divisible by 5, but there is no common factor between 3 and 4, so we have to stop here. And the highest common factor is the multiple of these numbers, 2 times 3 times 5. So it is equivalent to the 30, which is equivalent to the highest common factor. So 30 is the highest common factor. This is the same answer we got from the factor tree method. If you find that method easy, adopt this. If you find this method easy, adopt this. So totally choice is yours. So we have got the 30 centimeter or 30 as a highest common factor between the 90 and 120. So now we know that the length of the square tile will be 30 centimeters. Since the tiles are square, so this length will be this length will be equivalent to this length. And if this length is 30 centimeter and the total is 90 centimeter, we can easily calculate total number of tiles required to fill this row. Will be 1, 2 and 3. Since 90 divided by 30 is equivalent to the 3, so 3 for this row, and on 30 centimeter for this tile, and this is altogether is 120 centimeters. So 120 divided by 30 is 4 tiles. So 4 tiles on this side. So 3 and 4, 3 times 4, total number of tiles will be 3 times 4 is equivalent to 12. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 tiles will be square tiles will be required to cover 90 centimeter by 120 centimeter wooden floor. Factors of a number. What are the prime numbers? What are composite numbers? And how can we do prime factorization of a composite number? And how to find the highest common factor. Now there is another problem. The problem states that Susan has a rectangular patterns, each of a 30 centimeter by 36 centimeter. Okay, she wants to create a square using rectangular patterns. Can you help her to find the minimum numbers of rectangular patterns required to form a square, and also find the length of side of a square? Problem. She has a rectangular pattern, each of side having 30 centimeter and the other side is 36 centimeter. So she wants to join these rectangular patterns to form a square. As we know, the length of the sides of the square are equal, so we have to find something common between 30 centimeter and 36 centimeter. At this point, we should not find the factors, common factor between 30 centimeter and 36 centimeter. As we can see, 30 centimeter and the 36 centimeter are the factors of this line, of this length. So we need to find the common multiple of 30 centimeter and 36 centimeter. So in order to find the lowest common multiple, what we need to do is that we need to decompose these composite number into its prime factor. For 30, I am getting 2, 3 and 5 as a prime factors of 30, and for 36 I am getting 2 square and 3 square as the prime factor of 36. So in order to find the lowest common multiple, we will take the highest notation number which are common, and we will also take the leftover number which does not have any common number and multiply it. So in this case we are taking 2 square, 3 square and 5, and we will get the least common multiples of 30 and 36. So this was the factor tree method to find the lowest common multiple. We can find the lowest common multiple by using the division method of prime factorization. So let's see how can we use this method. So we have to write the same 30 and 36, and we have to start divided by the lowest common number, common factor. So for 30 I am getting 15 and 18. 15 and 18 are divisible by 3, so we will get 5 and 6. We does not have any common factor, so we have to stop our division here, and we will take the we will take the product of 2, 3, 5 and 6 to find the lowest common multiple of 30 and 36. So yes, these number and the remainder, the product of these number and the remainder will give us the lowest common multiple if we are using the division method of prime factorization to find the lowest common factor. So we have find that like 180 centimeter is a least common multiple of 30 centimeter and 36 centimeter. It's like that if we keep multiplying 30 centimeter and 36 centimeter by an integer, 180 will be the very first number which will be common to both multiplications. So the question was how many rectangular patterns are required to form a square. So we have found that the length of each side of the square is 180 centimeter. If this portion is taking 36 centimeter, so how many rectangular pattern will be required for this side? So 180 divided by 36 is equivalent to the 5. So 5 rectangular portion are required to cover this side, and this portion is taking 30 centimeter, and the total length of the square here is 180 centimeter. So 180 divided by 30, so we will get we'll get 6. Yes, so the 6 rectangular portion are required to fill this row. So 6 for this row, 5 for this column. So 6 times 5, total number of the rectangular patterns are required will be 30. So in this video we have learned how to find the factors, what are prime numbers, what are composite numbers, how to do prime factorizations, how to find the highest common factor, and how to find the least common multiples. So yeah, that's all for today. and don't forget to show your love and support to this channel by liking and sharing,